Greetings everyone. Today I will be sharing one of the projects that I have worked on. The name is Autism Spectrum Disorder Detection. Let's go to the contents. Of course, I am not going to go through all of the slides. The code will be coming at the very end. These are the contents, by the way. Of course, you should be knowing what is ASD. Just Google it, or you can also go through the slides. The cause of autism, I have shared some of the causes here. These are the signs, the treatments. Okay, the technology that is used in autism. These things are relevant actually. You can go through the slides. ML algorithms details. I'll not be going through it here. Okay, this is comparison and results. I also will share that in the code section. Okay, now coming to the system architecture, this is very important. First, what we have done, we have taken autism raw dataset, and this is not one dataset. Actually, there are multiple datasets that we have taken because there are some algorithms that need images and other algorithms that needs data, like in table row format. So this slide shares that the autism dataset that I have taken. After that, what we have done, we are doing reprocessing. And what is that? We'll go to the code and see that. Then loading the data to the cases through which we will be applying the algorithms or train the model. Then applying ML algorithms and applying DL algorithms. We can take both of those or any of those. I have taken both of those and compared the things. I'll just come to these things in the code. Then evaluation of ASD and no ASD classes. Actually, we'll be doing evaluation based on which algorithms are giving better results. These are the datasets, you can go through it. Now questions in dataset. What are these? Actually, these questions are properties on which we have trained our model. These are the evaluation charts. I'll be coming to that while sharing the code. These are the future plans, conclusion, references. Thank you. Now coming to the code. You can see what are the data that we have taken. These things are the basically properties that I have shared with you, like ID, A1 to A10 score, age, gender, all of those things. These are the libraries that I have used. You can see Scikit-learn for machine learning algorithms, Keras for neural networks, Pandas for data manipulation, NumPy for calculation, Matplotlib and Seaborn for data visualization. This is the visualization tab. Based on many things we have done the visualization, like how many of them are autistic, how many of them are not, then what are the percentage of that or total number of that, then from which continent they are or which area they are, then gender specific. These things you can go through. Yeah, dropping unuseful data and splitting the data, then standardizing, classification. Yeah, the first algorithm I have used is random forest, you can see here, and through the confusion matrix you can see the accuracy and all of those things. Then decision tree, ANN model I have used. Actually, I am not running this because it takes a lot of time to run the models, specifically ANN and the deep learning models. SVM I have used, logistic regression, naive Bayes, KNN, XGB, CNN, what was that, LSTM, DNN. Okay, now coming to the comparison part. After training our model, what we are getting, this is the comparison of accuracy. If you want to go to the exact number, I'll say coming to the confusion matrix and taking accuracy directly, this is giving the exact number. And after comparison of accuracy, coming to the comparison of precision, then comparison of recall, F1 score, support, and here it is the comparison of all of those things in one chart. You can see, if I read the chart for ANN, these red lines, this defines the accuracy. So I can see for ANN, the accuracy for non-ASD person is likely 0.82. For decision tree, it is likely 0.80. And the higher the number, it is better. Like for CNN, it is nearly about 0.92. Or for the naive bias, it is likely 0.84. Don't come to that. What is that? This is another measurement of precision. This is another graph or line telling the measurement of precision. So you cannot compare the red line with the blue line. All of these lines are independent. If you compare ANN with decision tree, the red line tells the accuracy, so you will have to compare here and here. And this is the comparison of all of those things for ASD people. Okay, so that's all. Thank you.